Okay, so we're going to talk about dynamic theory. We've already talked about equilibrium theory. So dynamic theory is a theory of Earth's rotation and tides that takes into account all the different forces and effects that happen on the Earth. For one, the Earth isn't straight up like this. It's on an axis, so the sun hits it at different points. Excuse me. Second, the Earth also has a phenomenon called the Coriolis effect, where because of how it's rotating, all the wind and water on it is moving well on top of it, but it's drifting towards the right. So when you look at the or how it moves in the northern hemisphere, it moves at a clockwork rotation, so like clockwise rotation, so it moves sort of towards the right. And then when you look at the south, because it's mirrored on the bottom, it's going counterclockwise. Even though the Earth's still all going one way, the drift looks different because of how the mirror image winds up working out. But that's basically dynamic theory. It takes into account just all the different forces. So yeah, like there's also solar tides and lunar tides pulling on it. It's not just the moon. So the so there can be multiple tides in different places. So the sun has a gravitational pull on the Earth's oceans as well. It's not as strong because it's farther away. So sometimes they are separate and they're pulling in opposite sort of perpendicular directions. That's called a neap tide, where things are a lot more mellow because the water's not all in the same place. And then, so you get like a more even distribution of water. And then there are things called spring tides, where the moon and the sun are pulling the oceans in the exact same direction. And that's where you have higher contrast between tides. So there's higher highs and much lower lows. But that's basically it for dynamic theory. I hope this worked.